Okay, now we have the notion of the covariance, and I just rearranged things on the board here a little bit to give myself a little more room. And now we're going to talk about the correlation coefficient that is most commonly used, and it's actually called the Pearson product moment correlation. You don't have to remember that, though. People just call it the Pearson correlation, or R, little r. You see that all the time. That's the Pearson correlation. And that's what we're going to teach you how to calculate right now. This is the most likely one that you'd ever see if someone talks about a correlation coefficient. They're probably talking about this thing. I call it the king god of all measures of association because it's so commonly used and it's so ubiquitous everywhere you go. One problem with the covariance calculation that we just did is that it's really sensitive to the metric of the variables you're using. If you have something that you're measuring that's in the hundreds, like IQ is around 100, and you're using some other variable that's also big, you put them together, you're going to get these really big numbers for the covariance, versus if you're using something that has smaller numbers, like our example here, GPA is something that has smaller numbers, you're going to get a smaller covariance even if the relationship between the variables is exactly the same, because you're subtracting and adding bigger or smaller numbers. And so we want to find a way to correct for that, so we have something we can compare across and we can say, oh, this one's got a correlation of 0.8 and this one's got a correlation of 0.4, and that comparison means something, whereas it wouldn't necessarily do so if you're talking about the covariance. Okay, so we want to correct for that. Okay, so one way to kind of correct for that metric is to divide by something that's going to put us all on a kind of standard scale. And the way to do that, there's different ways of doing it, but one way that you might immediately think of doing, since you've been in this course with me, is to divide by the standard deviation. The standard deviation tells us something about the spread of those variables. If we divide by those standard deviations, it's going to standardize our numbers so they're all going to kind of be on the same scale. And so all we really have to do is figure out a way to use the standard deviations of our x and our y with this covariance to correct it, and then we'll have something that we can compare across different kinds of situations. That's what we want to do. Okay? So, so conceptually, what we're going to do is we're going to take our covariance of x and y, all right? That's what this thing is up here, the covariance of x and y, and we're going to divide it by something to standardize it. And we've got x and y involved in here, so why don't we just divide by the standard deviation of x. Since we multiplied them together up there, let's multiply them together down here, times the standard deviation of y. And in fact, that's exactly what happens in the Pearson product moment correlation. All right, so all we really have to do is take our covariance formula, and then we have to take our standard deviation formula for x and our standard deviation formula for y and put them in here, and that's going to give us this R. That's all we have to do. Now, it looks like a mess when you put it all together, but if you just keep this concept in mind, you'll know exactly what we're doing. All right? So I'm just going to take a second here and put that formula up on the board, and then we'll go ahead and calculate the rest of this example and get us to R. Okay, so I'm back and I have my big formula here. Look at this thing, it's gigantic. It looks complicated. There's all kinds of little numbers and squiggles all over the place, but who cares? We know what all this stuff is. We just took this from up here, this piece right here, and these are our old friends, our standard deviation formulas that we covered earlier in the course. This is the standard deviation for x, so I'm just taking x bar and subtracting it from each one of the x's, squaring it, adding them up, and then dividing by n. Same thing we've done a million times already. And then same thing over here, except we're going to do it with the y's and the y bar. Same exact thing. Okay, so there's nothing complicated about that. You've done it before. It's very easy. It looks like a lot. We can actually simplify this a little bit using math that you probably learned in 6th grade or something. I'm not going to go through all the steps, but it turns out that you can cancel out these n's right here, make them go away. And so the final formula just looks like these parts here. And so I'll just go ahead and take a second and write that as the final formula. So the final formula is going to look like this, okay? It's just this top part over these bottom parts here. So it's 1 to n of I minus y bar. That's the top part, right? And then I just have these things in square roots down here in the bottom, and you can multiply them together and take the square root of the whole thing. So that just turns out to be the sum of I equals 1 to n of xi minus x bar squared times the sum I equals 1 to n of yi minus y bar squared. That's it. That is the formula for the Pearson product moment correlation. Okay? All right, so I'm going to take another second here and just give myself some room to do calculations. And I'm just going to retain this piece here. I'll move it up here to the top, and then we'll work through the remainder of the calculation. Okay, so all I did is move my formula up here. Now I'm going to do the rest of the calculation. But I want to point out one little thing I did. When I moved the formula, just to make it easier to see, since I'm writing it so small, I didn't write the little I equals 1 and the n on the top of each summation sign, okay? You can do that. You can leave that out. But when you do that, when you're dealing with formulas, just tell people that you suppressed those. You'll sound a lot cooler, and then they'll know you did it on purpose too. So I suppressed the I and the n business to make things a little easier to see. So I suppressed them. Yay. Okay, that makes you sound cool. All right. Now, so what do we need to do this formula? Well, we already calculated the top part. That's just the, it's like the covariance, except we're not dividing by n. So we're back to this number right here. That's the top number for this thing. So we're going to use that in a minute, but we already calculated that. We did the subtracting, and we did the multiplying, and we ended up with that. Okay? So now we just need these bottom parts. And so we need the sum of x sub I minus x bar, and we need to square that. Well, we already calculated x sub I minus x bar. We have all those here. So we just got to calculate the square of that. Okay, so we're just going to square this number. And so that first one is 0.16. Okay, and then we need to do the same thing with the y. So we need another column here that's y sub I minus y bar squared. And that first one, so we already calculated that part. It's 0.12, and so we just need to square that, and that's 0.0144. Okay, and so now I just need to go down and do that for each one of these numbers. So 3.6 squared will go here. 8.4 squared will go here, and so on. So I'll just go ahead and fill all those in, and we'll come right back and finish up. Okay, so I've calculated all those values out. So now all I have to do is add this up. So I'll add this one up, and that turns out to be 398.4. 398.4. And then this one added up turns out to be 3.8. Okay? All right, so now I've got this part in here, and this part over here. And so now I just apply those together. So 3.98.4 times 3.8, and then I'm going to take the square root of that. So what we have now is we've got this upper part, which is negative 25.7, and then the lower part we've got 398.4 times 3.8. Right? And so I just got to calculate that through, and it's going to give me R. The bottom part, so negative 25.7 divided by that thing down there is, if I multiply that out, it's the square root of 13.92. Still have 25.7 on the top. The square root of that is 38.91. Okay, And so the final value is, if I divide that, is negative 0.66. Negative 0.66. That's my R. I just calculated my first Pearson product moment correlation. Yay!